Hello everyone, welcome back to Math 1314, more in Math, Chapter 4, Section 5, Part 2. We're dealing with rational functions. Now we're going to look at some examples. So before we get doing the examples, remember, when we talked about asymptotes, we said that, okay, like in vertical ones you can't cross them, and horizontal ones, okay. Which ones can you cross? Because a lot of students always ask me, well, can you ever cross an asymptote? Well, yes, you can, but not all of them. So, one, you can never cross a vertical asymptote. Because they make the denominator equal 0, which makes it undefined equation. So, you can never cross a vertical asymptote. You may cross a horizontal or an oblique asymptote. But not all the time, only in some cases. So, here are our steps of solving these things. Remember, we have a rational equation, which is the top part is a polynomial and the bottom part is a polynomial. Right now we're going to look at the top and bottom have no common factors. If the top and bottom do have common factors, that changes a little bit because it changes the definition of our which vertical asymptotes we have. So the first thing you have to do, factor both numerator and denominators. Factor them out. Set the top p of x equals 0 and find the x-intercepts. The only way a fraction can equal 0 is if the top equals 0. So those are our solutions. If we set the top equals 0, set the bottom, the q of x equals 0, to find the vertical asymptotes. So set the top equals 0, solve it to find the x-intercepts, the zeros. Set the bottom equals 0 to find the vertical asymptotes. Set x equals 0 to find the y-intercept. Find the horizontal or oblique asymptotes. Those are pretty much the 5 steps. We did away with looking at what happens if we have the same top and bottom. We're not looking at that. We'll look at later on in one of the examples. So these are the 5 steps. Factor both top and bottom. Set the top equal to 0. Solve them. That tells you the x-intercepts. Set the bottom equal to 0. Gives you the vertical asymptotes. Set all the x's equal to 0, and what you end up with is the y-intercept. And then find the horizontal asymptotes. So, here's our first one. Two x plus 3 over 3x squared plus 7x minus 6. So remember our first step. Factor both top and bottom. The top is already factored. Let's see if we can do the bottom. Remember how we do that? Since our leading coefficient there. So we put the first term in both of those. Since the second sign's a minus, one's plus, one's a minus. And the bigger number goes to the plus. Take the first and the last term, so 3 times 6 is 18. Okay, I forgot. What multiples? What times what is 18? When you subtract them, you get 7. So we have 18 times 1 is 18. 9 times 2 is 18. 9 minus 2 is 7. Right? There we go. So the 9 goes at the plus, and the 2 goes in there. We can factor out a 3 out of the first one. Nothing factors out of the second one. So the bottom part factors out into x plus 3, 3x minus 2. So A. The x-intercepts. Set the top equal to 0. So 2x equals negative 3, x equals negative 3 over 2. So that's my x-intercept. Negative 3 over 2, 0. The vertical asymptote. Set the bottom equals 0. So we have x plus 3 equals 0. 3x minus 2 equals 0. So we have x equals negative 3. Can't use that. 3x equals 2. X equals 2 over 3. So those are my asymptotes. So my domain is between here. So that's our domain. Let's find the y-intercept. So we have 2x plus 3, 3x squared plus 7x minus 6. Remember here you set x equal to 0. So anything that has an x, just get rid of it. The y-intercept is only the constants. So it's a negative 1/2 because it's a negative on the bottom. So the y-intercept is at negative 1/2. So we have the zeros, the x-intercepts, we have the y-intercept, and that. Let's see what else we need. Okay, we got the y, q0, horizontal, the horizontal asymptote. Two x plus 3 over 3x squared plus 7x minus 6. All you care about is the leading terms, 2x over 3x squared. The bottom's bigger than the top, so the horizontal asymptote is 0. And you gotta plug in some points. Let's see what we have here. Okay, so here's our graph. So let's look at first our vertical asymptotes are at -3, so I can't cross that line, and at 2/3. So 2/3, so about here, I can't cross that. My horizontal asymptote is the x-axis. And my y-intercept is at -1/2. So -1, -2. My x-intercept was at -3/2, which is -1/1/2. So since it's an x squared, this is what these sides of the graph look like. And plug in some points and you'll see it looks like this. Alright, let's look at another one. F of x equals x squared minus 1, x squared plus x minus 6. So the first thing I do is factor out the top and bottom. So since this is a difference of two squares, we have x plus 1, x minus 1. So we have x and x, opposite signs. What times what is 6 when you subtract them? You get 1, 3, and 2. So the x-intercepts. Set the top equal to 0. So we have x plus 1 equals 0 and x minus 1 equals 0. So x equals -1 and x equals +1. These are my x-intercepts. The vertical asymptotes. The bottom equals 0. We have x plus 3 equals 0, x minus 2 equals 0. So we have x equals -3, x equals 2. Let's look at the horizontal asymptote. Where all we need are the leading coefficients. So the leading coefficients, x squared over x squared, since they're the same, it's just the coefficients. So the horizontal asymptote is the line y equals 1. And the y-intercept. X squared plus x minus 6. Anything has an x, get rid of it. So we have -1 over -6. The negatives cancel, so it's 1 over 6. So it's at 0, 1 over 6. Let's look at the graph. My sheet here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4. -1, -2, -3, -4. So the x-intercepts are at -1 and 1. The vertical asymptotes are at -3 and +2. The y-intercept is at 1/6. What else do we have? Oh, the horizontal asymptote is at 1. Okay, so since these points are down here, that one's up there in the center, so I'm looking at the graph here, it will look like that. Since they're both x squared, no matter what we put in here, the answer will never be negative. Again, you just plug in some points. Plug in 3, 4, this will be positive. If you put -4, -5, it's going to be positive. Okay, let's see what's the next one I'm going to look at. Actually, yeah, there's something I was going to look at here. Okay, so the okay. Okay, let's look at the next one. 2x cubed x squared plus 1. First one, the x-intercepts set the top equal to 0. So x is equal to 0. Look at the y-intercept. So that's 0, so it's 0 over 1. So it crosses through the origin. The vertical asymptote, set the bottom equal to 0. So x squared equals -1. Square root both sides. So positive negative I. So no vertical asymptote. Horizontal asymptote. Since the top is bigger than the bottom by 1, no horizontal asymptote, but an oblique. So we have x squared plus 1 goes into 2x cubed. X squared times what gives 2x cubed, so it's 2x. 2x times x squared is 2x cubed. Plus 2x changes signs. Negative 2x. Since x squared is bigger than that, so we have an oblique asymptote at 2x. So when x is 1, y is 2. When x is 2, y is 4, so it looks like this. That's the oblique asymptote. The graph crosses at 0, 0. Plug in some points. When x is 1, so our equation when x is 1, so it's 2 over 2, which is 1. When x is 2, so it's 2 cubed 8 times 2 is 16. 16 over 5 is 4. So this side looks like this. At -1, it's -2 over 2. It's at -1. So it's going to be symmetric. So that's what it looks like. Okay. Another example. Let's do a couple more. F of x equals x minus 2, x squared minus x minus 2. Now, what if the top and bottom share a common factor? So we have x minus 2 on top. The bottom factors out into x and x. Opposite signs. What times what is 2? And you subtract them is 2 and 1. So negative is 2. So we see here our vertical asymptotes are negative 1 and 2. Our x-intercept is at 2. Our horizontal asymptote, since the bottom's bigger, is 0. Our y-intercept, get rid of the x's, so it's negative 2 over negative 2 is 1. So far, this is what it looks like at this stage. But if you cancel out common factors, we just used to have our vertical asymptote as negative 1 and 2. Now we lost the 2 no longer there. So our vertical asymptote now is at negative 1, because you said that equals 0. The x-intercept is now at, there is no x-intercept. Because to find the x-intercept, you have to set top equals 0. The horizontal asymptote is still 0, because the bottom's got more x's than the top. And the y-intercept remains to be 1. So, what about the x minus 2 part? Since we removed it, we now have a whole at x equals 2. X minus 2 equals 0, x equals 2. So we have 2 minus 2, 2 squared minus 2 minus 2. Uh-oh, now we have a bigger problem. We can't look at, since we got lost, we can't use the original function. If we plug in that, we get 0 over 0. So we have to use the simplified function. One over x plus 1. So at 2 1/3, we have a hole in our graph. we graph 1 over x plus 1. So if you cancel anything, it's whatever you end up with, that's the function you're going to use to graph it. So at 2 9/3, we have a hole in our graph, and we graph this function, the simplified version. So f of x minus 2, x squared minus x minus 2 Where this is similar to what we did earlier. We have the function 1 over x, which looks like this. We shifted it to the left one space. So there's our graph. At x equals 2, we canceled the x minus 2's. So at 2 1/3, we have a hole. So whenever you cancel something on top and bottom, you graph the remainder function, but whatever you crossed out, that value, you put a hole in it. Let's try one more. Negative 2x squared minus x plus 15, x squared minus x minus 12. So the first thing we have to do is factor these things out. Since that's a negative there, we take out the negative. In other words, we change the signs of everything inside there. Now we're ready to factor it. Two x squared plus x minus 15. So we have 2x, positive, negative. 2 times 15 is 30. What times what is 30? When you subtract them, you get 1, 6, and 5. So the 6 goes in the pus. Factor out of 2. So it equals x plus 3, 2x minus 5. That's the top one. X and x, opposite signs. What times what is 12? Subtracted, you get 1, 4, and 3, so the 4 gets the bigger one. Negative. Vertical asymptotes are at negative 3 and positive 4. But x plus 3 cancel. So our domain of this one is from negative infinity to negative 3, negative 3 to 4, 4 to infinity. Alright. But now that we simplified that, we now have negative 2x minus 5 over x minus 4. And our asymptotes are still negative 3 and 4, but that's going to be a whole. So this is the graph function we have to graph. Okay, this. We simplified this one to being negative 2x plus 5. This one was x minus 4. We got rid of the x equals negative 3 part. Alright, so we have our vertical asymptote at x equals 4, the horizontal asymptote at negative 2, because that's what we have on top. So we had negative 2x minus 5 over x minus 4. The x's cancel, so we have negative 2. Look at the graph of this thing. So at negative 2 is our horizontal asymptote. 1, 2, 3, 4. That's our vertical asymptote. It's negative. Since the functions are squared, they can never be negative. Well, since they cancel out, this is simplified this. This is 1 over x. Remember, the 1 over x functions like this. But since it's negative, it's now going to switch. So our graph when our x-intercept is going to be at negative 2x minus 5, set it equal to 0. So x equals negative 5 over 2, negative 2 and 1/2. So it's negative 2 and 1/2, so it's there. Or is it? No, it's going to be negative 1/2, because the negative 2 is a horizontal asymptote. Oh, the y-intercept, I'm sorry, it's negative 15 over 12. 3 goes in both those, just negative 5 over 4. That's what it is. So it's negative 1 and 1/4. Just put it right there. And 0, the x-intercept, is at, that's going to be at 5 1/2, that's 2 1/2. So it's going to cross here. But yeah, that's pretty much what I can. I was just in a hurry. All right, that's it for section section 5. All right, good luck, everybody.